Welcome to Deep Dive Learning by HaleForm.
Episode 11.
Today we're really getting into something core for big engineering projects. Collaboration across different sites using Intergraph Smart 3D's global Workshare configuration. You'll often hear it called GWC.
Exactly. And for our discussion, we're drawing on some insights from HaleForm Technology Solutions, who work a lot in this space, plus a very practical guide about, well, troubleshooting the database sync issues that can pop up in these GWC setups.
Right. So for you, the learner, maybe you're already involved in complex plant design, or maybe you're just curious about how these massive projects come together. This deep dive should give you a really clear picture of how teams, often continents apart, can work on one giant 3D model.
And importantly, what kind of challenges they might face along the way. We'll try to unpack some of that complexity.
Definitely. And offer some insights into keeping things running smoothly. So let's start at the beginning. What is Smart 3D GWC, fundamentally?
Yeah, think of GWC as the enabling technology. It lets teams spread out geographically, all work together on the same Smart 3D plant model, pretty much at the same time.
Like different specialists in different cities all adding their parts to the same blueprint, but a digital one.
Precisely. A very detailed digital twin.
Yeah. So how does that actually work? How do they all stay in sync?
The core idea is data replication. The system constantly copies model data between a central host location and multiple satellite locations.
Okay, host and satellites.
Right. And this replication aims to give everyone near real-time access to the latest version of the model, wherever they are.
Near real time.
Yeah.
That sounds technically demanding. What's under the hood? What tech makes that happen?
You typically see powerful database technologies doing the heavy lifting. Often it's Oracle databases using a tool called Golden Gate for replication.
Okay.
Or if the project uses Microsoft SQL Server, then its built-in replication features are used. These are pretty established technologies for this kind of continuous data movement.
So data is flowing back and forth all the time. Host to satellites, satellites back to host.
Exactly. Changes made at the host get pushed out. Changes from a satellite go back to the host.
Right.
And then, crucially, the host sends updates that gets from one satellite out to all the other satellites.
Ah, so the host is like the central coordinator?
It's a classic hub-and-spoke model, yeah.
Yeah.
Very efficient for distributing changes widely.
Interesting. Now, what about things like project reports? Are those flying back and forth too?
Generally, no. Reports databases are usually regenerated locally at each satellite.
Why is that?
Well, it's often more efficient. It uses local computing power and avoids sending potentially large report data sets over the network.
Yeah.
Cuts down on traffic.
Makes sense.
And it's also worth mentioning the catalog data, piping specs, equipment details, all that foundational stuff synchronizing that follows its own specific set of procedures within GWC. It's managed very carefully.
Oh.
And that's an area where HaleForm Technology Solutions, for instance, have a lot of expertise managing and customizing those catalogs to make sure everything's consistent everywhere.
Right. So the big picture goal is consistency. Everyone, everywhere, working with the same current information.
That's the absolute aim. But, with any complex distributed system like this, you're bound to hit some bumps. Synchronization issues can definitely happen.
Okay, let's dig into those potential bumps. What's a common problem teams might run into?
Probably the most frequent one is replication lag. Basically, delays in seeing changes made elsewhere. Or in worst cases, replication might stop altogether.
And how would a team know they're experiencing lag? What are the symptoms?
Well, users might just notice it takes a long time, maybe hours, for changes made at the host or another site to show up in their session.
Frustrating, I bet.
Definitely. You might also see, if you look at the monitoring tools like Golden Gate Monitor or the SQL Server Replication Monitor, that there are queues building up, data waiting to be sent or applied, like a traffic jam.
A data traffic jam. Got it.
And eventually, this lag can lead to actual inconsistencies, different people seeing slightly different versions of the model, which is obviously problematic.
Obviously. So what causes these lags or failures? What's behind the traffic jam?
It can be a few things. Network problems are a big one. High latency for the delay in data getting from A to B is often more damaging in GWC than just low bandwidth. Intermittent connections, dropouts, those are killers too.
So stable, low-latency networks are key.
Absolutely critical. Then there can be issues with the replication software itself. Maybe a processing Golden Gate the manager, extract, or replicate has an error, or one of the SQL Server agents isn't running correctly.
Okay.
Database server performance is another factor. If the server hosting the database at the host or satellite is overloaded, CPU maxed out, memory issues, slow disk I/O. It just can't keep up with the replication demands.
Right, the servers themselves need to be healthy.
Yeah. And then there's configuration. Sometimes the GWC setup itself wasn't done quite right, or maybe database parameters weren't set correctly, like forgetting supplemental logging in Oracle, which replication often needs.
Little details that have big impact.
Exactly. Even just a massive bulk data load, like importing a huge amount of equipment at once, can temporarily strain the system. And don't forget firewalls. If the ports needed for replication communication are blocked between sites, nothing's going anywhere.
Wow, quite a list of potential culprits. So if a team suspects replication issues, where do they start troubleshooting?
First step is always check the status monitors. See what Golden Gate Monitor or SQL Server Replication Monitor is reporting. Are there errors? Are queues growing?
Get the real-time picture.
Precisely. Then check the network. Basic connectivity tests, ping times, trace routes between the hosts and satellites to assess latency and stability. Dig into the logs, the Oracle Alert logs, the Golden Gate Error log, AG-subcr.log, SQL Server error logs, the replication agent logs. They often hold specific clues.
Lots of log diving.
It often comes down to that, yeah. Also, double-check the GWC configuration against the official Hexagon documentation. Were all the prerequisites met? Are the settings correct?
Yeah.
Check server performance, CPU, memory, disk I/O on all involved servers, and finally verify those firewall rules. Make sure the necessary ports are open.
Okay, pretty systematic approach. Now, what if replication seems okay, the tools say it's running, but teams are still seeing different things in the model, data mismatches?
Right, that's the next level of headache. Data mismatches or even conflicts between locations.
What does that look like in practice?
You might have, say, a specific pump.
Yeah.
At the host, its properties say one thing, but at a satellite, they look different. Or the geometry, the 3D representation itself might vary slightly.
Uh-oh.
Yeah. Or reports run at different sites give conflicting numbers for the same items. And users might get errors when they try to modify an object because the system detects an inconsistency.
So if replication is supposedly working, what causes these kinds of discrepancies?
Well, first, you have to be sure replication is truly caught up everywhere. Even short lags can cause temporary mismatches. But beyond that, if the replication uses conflict resolution rules, maybe those rules are misconfigured.
Conflict resolution?
Yeah, rules about what happens if the same object is changed simultaneously at two different sites. Like who wins. If those rules aren't set up right, data can get overwritten incorrectly.
Okay.
Another potential cause, though it shouldn't happen, is someone making manual changes directly in the database at a satellite, bypassing replication entirely. Big no-no. And sometimes there can be issues with a background service called the Duplication Synchronization Service, or DUSS, which handles some consistency tasks.
So how do you track down and fix these mismatches?
Again, first confirm replication is healthy and fully caught up. That might resolve it on its own. If not, you need to identify the specific objects that are inconsistent.
Pinpoint the problem areas.
Exactly. Then you compare the data for those objects at the host and the affected satellites. Smart 3D tools can help, or careful read-only database queries. Checking audit trails, if they're enabled, might show who made unexpected changes. Verify that DUS service is running correctly everywhere.
And if it's really bad?
As a last resort, and only by strictly following Hexagon's procedures, you might have to consider what's called amputation and reduplication. Essentially, disconnecting a problematic satellite, cleaning things up, and then recopying the entire model data to it from the host. It's a major operation, though.
Yeah, sounds like something to avoid if possible. Let's shift slightly. What about issues specifically related to synchronizing the model with the project catalog? Or generating model views?
Ah, yes, that's another common friction point, the synchronize model with catalog command.
What goes wrong there?
Well, the command itself might just fail on the project management tool, maybe spitting out an error message. Or model views that the satellites don't update properly, so users aren't seeing the latest geometry or data. Sometimes you get specific errors like object not synchronized with catalog.
And what's usually behind those errors?
Often it's about the catalog itself being out of sync. Maybe the host catalog was updated, but those changes weren't properly pushed out or made accessible to the satellites before someone tried to synchronize their model. Timing is key.
I see.
It could also be simple permission issues. The user running the sync doesn't have the right database rights. Or maybe there are connectivity problems between the tool and the databases. And rarely there could be actual corruption in the catalog database, usually at the host.
So, troubleshooting catalog sync issues.
Number 1, make absolutely sure you're following the correct documented procedure from Hexagon for catalog synchronization. Usually sync the catalog first, then the model. Verify that all sites can actually access the shared network location, the shared content folder where the catalog lives.
Check access, check permissions.
Exactly. Check the user's permissions. Dive into the synchronization logs. They often have very specific error details. At the host, consider running database integrity checks on the catalog database. And at the satellites, if views are stale, you can often force a regeneration using the synchronize command or the view generator tool.
Makes sense. And again, having well-managed catalogs is crucial here.
Absolutely. And that's where expert administration, like the services offered by HaleForm Technology Solutions, can really help prevent these kinds of catalog-related headaches in the first place. They ensure everything is properly maintained and synchronized.
Good point. Okay, let's talk about people and permissions. Who gets to do what? Can that cause problems in GWC?
Oh, definitely. Permission group and access issues are another category.
What does that look like for the user?
A user at a satellite might find they can't claim an object to modify it, even though they think they should have access. Or they get errors related to permission groups when trying to perform certain actions, especially on objects owned by another location.
Why does that happen in a distributed setup like GWC?
The key thing to understand is that permissions, who's in what group, what rights each group has, are primarily managed at the host. Those settings are then replicated out.
So it's centralized management.
Mostly, yes. Certain admin tasks for permissions only happen at the host. So sometimes issues arise just because someone doesn't realize that, or they're trying to change something locally that needs to be done centrally. Also, there's that replication lag again. A permission change made at the host takes time to reach all the satellites.
So someone might not have the permission yet.
Exactly. And if the project uses intercompany fabrication, IFC, there are specific permission setups needed at the satellites for that workflow to function correctly. Misconfiguring those IFC permissions can cause access problems too.
So troubleshooting permissions.
First, check the user's setup and the group permissions and project management at the host. Confirm everything looks right there. If changes were just made, give replication some time to propagate. If IFC is involved, meticulously check the IFC permission setup at the satellites against the documentation. And always check who currently owns the object in question. That often dictates who can modify it.
Okay, one last area, the to-do list in Smart 3D. Can GWC cause specific errors there?
Yes, it can. You might see errors like delete connections popping up. This often happens when an object is deleted at one location, but it had connections to objects that are owned by another location.
Cross-location dependencies.
Right. Or users might find they just can't resolve certain to-do items that seem related to these GWC operations.
What's causing those to-do list entries or errors?
Sometimes, these records are actually just part of how GWC normally works, logging actions that span locations. The delete connections might be informational. But if a user can't resolve an item, it might be because they lack right permission for the objects involved. Or it could signal a deeper data inconsistency that needs fixing first.
So how to deal with those?
First, try to understand what the to-do record is actually about, what GWC action triggered it. Then, ensure the user trying to resolve it has the necessary permissions. If it seems tied to a bigger data problem, you need to address that underlying issue first. And sometimes, if the to-do list views themselves are lagging due to replication delays, a manual update or refresh might be needed at the satellite.
This has been really comprehensive, covering a lot of potential pitfalls. To wrap things up, what are the absolute must-do best practices to prevent these sync issues as much as possible?
Prevention is definitely key. Number one, a rock-solid network. Stable, reliable, enough bandwidth, but critically optimized for low latency between all sites. That's paramount.
Network.
Absolutely. Number two, follow the book. Strictly adhere to Hexagon's documented procedures for everything. GWC setup, admin, backups, recovery, maintenance. Don't cut corners.
Stick to the plan.
Exactly. Number three, monitor proactively. Regularly check replication status, server performance, system logs. Catch small issues before they become big ones. Number four, controlled changes. Use proper change management if you need to modify GWC settings or database parameters. Don't just tweak things on the fly.
Right.
Number five, rigorous backups. Back up all databases at all locations regularly following Hexagon's advice. And, crucially, test your restore process periodically to make sure it actually works.
Tested backups are essential.
And finally, number six, trained admins. Ensure your smart 3D administrators really understand GWC concepts and how to perform the required tasks correctly. It's complex stuff. And this really highlights the value of experienced administrators. Teams like the SPID and Smart 3D admins at HaleForm Technology Solutions live and breathe this stuff. They can manage these complex GWC environments effectively for both host and satellites. Their expertise in setup and ongoing maintenance is often invaluable. If you need that kind of help, you can reach them at business.development@haleform.com.
So it's clear, isn't it? QWC is incredibly powerful for enabling global collaboration on these huge designs, but it definitely demands careful planning and management.
Absolutely. Understanding these potential sync challenges we've talked about and really embedding those best practices for prevention and troubleshooting, that's what keeps projects on track.
Yeah, the whole process of managing data across distributed sites really shines a light on how critical good infrastructure, solid procedures, and skilled people are, like those experts you mentioned at HaleForm Technology Solutions, business.development@haleform.com.
Exactly right.
This deep dive into smart 3D GWC sync, hopefully it's giving you, the listener, a clearer view into the world of modern engineering collaboration. Maybe it sparked some questions for you. What other parts of these distributed workflows are you curious about? Did anything we discussed trigger an aha moment for you?
And maybe think about how these ideas, data consistency, network reliability, careful process, apply elsewhere.
Right.
And other collaborative tools or systems you might use. The core principles often carry over.
That's a great point. Well, thank you for joining us on this deep dive today. We really hope it's provided some valuable insights into the fascinating complexities of global engineering collaboration.